Okay, so let's go through these notes. Now, here we have a word problem. So the first thing that I'm going to do is James stood on a flat field, blah, 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 blah. What is the question? I'm going to highlight the question. What is the range of the function representing the basketball's height? So, step one, that's the equation. So we're going to type f of x equals negative 4x squared plus 12x plus 2 into Desmos. Now notice that this is a parabola. It's a parabola because it's a degree of 2, or I haven't talked about this in AFDA, never mind. It's a parabola because it's got an x squared in it, right? This is a quadratic function. So it's a parabola because this is a quadratic function, and we're going to type that in Desmos. So I'm going to show my Desmos real quick. We're going to type in negative 4x squared plus 12x plus 2. And we get this nice parabola shape. Alright? So note that we're trying to find the range. The range is the y values. So we know that they stop here at 1.5 comma 11. And they start, they go down all the way to negative infinity. So the range is going to go from negative infinity, and we know it's negative infinity because we can keep going down forever. Right? We can keep going down forever. But we know that it goes from negative infinity up to 11. So you might think right off the bat, the range of this is going to be negative infinity to 11. And I want you to write that off to the side here with a question mark. And make sure that you include the question mark. But what's interesting is that we're looking at a basketball. All right, we're looking at the height of a basketball. So this is its trajectory. If we go back to Desmos, this is its trajectory. A height of 0 represents the ground. Now when the basketball hits 0, what's it going to do? Is it going to bury itself in the ground? No, it's going to bounce. And so does it ever go below 0? The basketball's height cannot go below 0. So we're really looking at a range that is what we call constrained. All right, there's a constraint that's applied to the range. So we can't just consider it the range of the entire function. The range of the basketball's height is constrained by the ground. So in this case, the range is limited, or the range must be all numbers from the ground to the peak of the trajectory, which is 11. So all of the numbers, and if you want, you can put these are the y values, not just any numbers, but these are all of the y values. All of the y values from the ground, which is 0, to y equals 11. So the real answer to this question is from 0 to 11. All right. Now you may get like one question like this on a test, and it'll only be worth like 1 point. All right. This is more of a bonus question to get you thinking. All right. A quadratic function is shown on the graph below. Now this quadratic function is infinite, so let's draw some arrows. All right. Now, which statement best describes the domain and range? Okay, on the camera it's not showing very well. But it says the domain and the range is all real numbers. the domain is all real numbers, and the range is all real numbers greater than or equal to 2. The domain is all real numbers greater than or equal to 3, and the range is all real numbers, or the domain is all real numbers greater than or equal to 3, and the range is all real numbers greater than or equal to 2. So, what this means, all real numbers is the same thing as negative infinity to positive infinity. But is that really what we're looking at? Like, for example, for A, the domain, the domain goes all the way left and all the way right because there are arrows on both sides. There are arrows pointing left and right. So yeah, the domain is all real numbers. But the range is not, because the graph doesn't go all the way down here. It starts at 2 and then goes all the way up. So because the range is not all real numbers, we can eliminate A. A better way to put this is the domain does go from negative infinity to positive infinity, but the range starts at 2 and then it goes up to infinity. So we need to figure out which answer choice in word form best models our interval notations. Now let's read the next one. The domain is all real numbers. And the range is all real numbers greater than or equal to 2. So that's every number that's at least 2. So that's going to start at 2 and then go all the way up. Oh, look at that. Look at that. We got a matching domain and a matching range. Now you can go through these last two and you'll find that they're wrong. These are in fact, or this is in fact the correct answer, B. Okay, again, this is more of a bonus topic. When we get back, or when I get back on Wednesday, this is going to be a little bonus topic, like a critical thinking question in your stations activity, and then we'll go from there. Okay, so let's flip to the back. Okay, let's talk about specific domain and range. This is something that might be a little bit more seen on your test. So, the range of this function along the interval 2 is less than or equal to x is less than or equal to 6. Let's highlight that, or circle it, or whatever you want to do. Highlight it, circle it, underline it, whatever you want to do. Make sure that it stands out. Now, from 2 to 6, this is all of the x values from 2 to 6. This is essentially the same thing as this interval here. So we're looking at all of the x values from 2 to 6 right here. And we're looking for what the range is along these x values. So in other words, we're only looking at the part of the graph that's in this area here. It stops right here. So we're only looking at this part of the graph right here. That's it. So every other part of the graph we're going to disregard, and we're only going to find the range along this particular set of x values, or this particular part of the function. So the y values start at, what is this, 1, 2, 3 down, which is negative 3. And they go up to, what is that, 5. So we're going to call this range from negative 3 to positive 5. There we go. All right, the next one. So this here we're trying to find the domain of this function along this interval, and this is from all the y values from -3 to 0. Now, I want you to keep in mind that from -3 to 0, these are y values, and therefore we're looking at the y values from -3, which is here, up to 0. So just these y values. So we're only looking at the graph in this part. We're only looking at this part of the graph right here. Because everything else we can disregard. It's outside of this interval. So now we're going to find the domain within this part of the graph. And it starts at, what is that, -1, and goes to 0. So my domain is going to go from -1 to 0. Okay, for this next one, find the range of f of x equals x minus 1 cubed along that interval there. Now, what I want you to do is type this in Desmos. And I don't just mean type the first line. I mean type this. And then, on the next line, just like that. Now we're going to zoom out so that we can see the edge, or so that we can see where the function crosses both edges of this little shaded area here. And if we click on the blue function, we can see the two boundary points here. Now because we're looking for range, the problem is asking for range, we're going to use the y values and say that it goes from 0 to 27. Oof. Now for the last one, what I want you to do, let me just show, yep. So for the last one, you're going to be typing in f of x equals x minus 5, and then that expression here, and then I want you to find the domain within the shaded part of the function. After that, you have 7 different expressions. I want you to write an interval notation, which is just the notation with the brackets and parentheses. If you get stuck, or if you finish, then I want you to work on the Desmos activity. I'm going to be posting another one soon. It may already be posted, but I want you to be working on that. Okay? So work on this problem, work on the remaining problems down below, and then I want you to finish the student Desmos activity, the activity in student.desmos.com.